Welcome to SuperGrid Institute. SuperGrid Institute is an independent research and innovation center dedicated to developing HV and MVDC technologies and integrating renewable energy into the power grid of the future. We are delighted to be part of the European PROMOTioN project working on an HVDC GIS technology demonstrator.
An important mission of the PROMOTioN project is to increase the readiness level of new technologies required to implement a highly meshed offshore grid, such as HVDC gas-insulated switchgear. It is very important to thoroughly investigate the operating behavior and electrical performance of new eco-friendly insulating gases using state-of-the-art diagnostic technique. As work package 15, we have found the right partner in SuperGrid Institute.
At SuperGrid Institute, we have been studying partial discharge characteristics observed within different gases in our dedicated test platform. The aim is to evaluate the effects of SF6 alternative gases in the partial discharge characteristics and study the effectiveness of different monitoring systems. This research is carried out with a view to develop more eco-friendly SF6-free direct current gas-insulated switchgear. Let's have a look at how the platform works.
A diode rectifier converts AC voltage into DC voltage of up to 850 kilovolts. To protect the diode against breakdown, we add a resistor. Then we use a coupling capacitor to perform the partial discharge measurements. Now let's start the test. First of all, we purposefully introduce a defect inside the GIS to study the partial discharge characteristics. In addition to the conventional measurements obtained using a coupling capacitor, we also use non-conventional systems such as pulse current, ultra-high frequency and magnetic field measurements. The latter was developed at TU Delft for this project. Multiplying the systems allows us to verify the measurements and evaluate the sensitivity of different monitoring systems. At this point, the test compartment pressure is reduced to 1 millibar and is then filled with the test gas, such as fluoronitrile CO2 mixtures or fluoroketone dry air mixtures, and of course SF6 for comparison purposes. When the voltage is higher than the partial discharge inception voltage, we can see that the partial discharge signals are detected and recorded by the different measuring systems. We proceed to compare the partial discharge characteristics of the tested gases with different voltage polarities and defects. This allows us to better understand the partial discharge behavior of each gas and to compare them against the SF6. Thanks to this test rig at SuperGrid Institute, with a background noise of less than 1 picocoulomb, we can accurately record partial discharge signals and compare and analyze the results. We can clearly identify differences between the SF6 and alternative gases. However, we note that the partial discharge monitoring system developed for the SF6 gas can also be used for substitute gases without any major modifications. Beyond the results, the success of this project speaks to the benefits of collaboration between academia, industrial players and research institutes.